Hi everyone, welcome to my channel. If you're new to this channel, kindly subscribe and hit that notification button to always get my updates. In this short tutorial, I'll talk about Python variables, Python data types, basic operators, and the inputs. So let's get started. So what's a variable? A variable is anything that can be changed. Let's try to use some examples here by setting x being equal to 3. Okay, let's try to understand this statement. It means x equals 3 means in Python receives 3, stores it in a computer's memory, and then assigns it to x. Alright, so what we mean by x is like a name and 3 is a value. In other words, x is like an identifier. Alright, so let's try to print x. It will give us 3 because now x is assigned to 3. If we say x equals 7, what happens to x? Alright, so this means that if I call x again, it will give me 7. What does this mean? It simply means that in the computer's memory, now x is stored as 7. So that means x has been changed from 3 now to 7, and that becomes a varying type of term, which is now what we call our variable. Alright, so also we need to understand how Python executes its statement. It executes the statements from right hand side towards the left hand side. Alright, so that means that when you set x to be equal to 10, Python first of all inputs 10 and then stores it somewhere in the memory and then later assigns it to x. So that means if x already exists, x is going to be moved from the other position of memory now to the new position of memory. And that's why when you call x again, sorry, this is supposed to be commented. Alright, when you call x again, this is going to give you 10 because it has been shifted from 3 to 7 now to 10. But how about if I write it as 10 equals to x? Alright, so if I run this, it will give me an error. Right, why? Because x in the memory it's not given any space. Alright, so and it is reading from this way towards the right, so it's not within the memory, right? But it's just an identifier. But if you just change it left to right and then so that it is x equals 10, then it will be not giving you an error. Alright, one thing we can understand here is that under variables we cannot use like data types to mean that variable. What I mean in this way, I cannot say 2 equals maybe 3 or 4. Alright, that is not going to work. Alright, because first of all this is a data type and this is a data type. Even if I was to use another data types, it would give me an error of this form. Alright, so that gives us the basis of what a Python variable is. A Python variable is something that we can always change in our program. Alright, and assign it to something different. So let's try to look at Python data types. So what are the given data types that do exist within Python that are inbuilt? First of all, we have those that can categorize to be as numerical. Alright, and under this we have several of them, like integers. We have floating numbers or float, and then we have complex numbers. Alright, so let's look at each of these ones briefly and then we move to another data type. So basically these three are categorized under the numerical data type, and so under this we can have different operations that can apply on them. So basically, what is an integer? What is an integer? Alright, so the easiest way to understand this is to use an assignment and to know the type of that data. Let's say x equals 2. All right. If I run this, x equals 2, I simply come up with a 2. So let's try to check. Python has a built-in function that checks the type of the data. Let's check the type of x. It will give us int. So this is telling us x is an integer. Let's try to look at x equals 2000, and then finally we can say type of x. It will tell us x is an integer. All right, which doesn't it doesn't matter what number you are using, but what matters is the type. All right, so basically this drives us to our simple definition or basic understanding of what an integer is, as any number that doesn't contain any decimal point, any number with no decimal point, all right, can be regarded as an integer. A float is any number we can quickly say that contains any decimal point. So if x equals going to use the same number 2.0, which can be the same as 2.00 for as long as the rest are zeros, we can write it as 2 point. All right, so if I try to find out the type of x right now, it will tell us it is a float. All right, so and likewise, if I try to check the type of, say, 2000.005, it will give me directly that is a float number. So right now we can say that float number contains at least a decimal point. All right, a decimal point. So that is the quick understanding of an integer, a float, and then finally we can look at what a string, what a complex number is. So basically a complex number is a number that is represented in two parts, a real and an imaginary part. So for example, if s equals 2 plus 3j, if you remember that from complex numbers, all right, so if I try to find out the type of s, it will simply give me complex numbers. These are all built-in functions for Python. All right, so Python knows that if a number has these two parts or has a j in it, then that is supposed to be categorized as a complex number. There are several operations that you can do in terms of complex numbers, as in the same way as these ordinary numbers. All right, so this is the first part of the data types that are built in within Python. All right, so let's look at the sequential numbers. All right, Python has another built-in sequence data type, or numbers stroke data type, which is of the sequential type. All right, so what does this mean? Python has several forms of representing data, and the next main category is a sequence data type. From this category, we have what we call lists. We also have what we call tuples or tuples. All right, and then finally we have also another category, which is range. All right, so let's look at each of these three categories quickly and see how do we create lists. Let's call L being a list. A list is created by just square brackets, and then you have the terms within inside, like 1, 3, 5, minus 10, 0, and then 2. All right, so it doesn't matter what order you are representing these terms within the square brackets. So if I run that and then try to check the type of L, all right, so this is going to tell me this is a list. And if I try to call auto print is a function that tries to get the results and prints the results on the screen. So if I print L, sorry, capital L, right? It will give me 1, 3, 5, 10, and so on, as in the same order as it was given. Let's try to have maybe S, another type of list, be equal to minus 10, all right, including some what we call string er, all right, 0, and then maybe 3, and then minus 1 in any order, any number, any given data type, and so on, right? So as you can see, we have some integers and so on and so on, and then you have also another type which we'll look at as a string. And then if we run that and then simply check the type of S, it will give us string, and it will not alter the order. All right, so this is how you can form a list. So now the second one is the tuple or tuples. So how do we create a tuple or a tuple? A tuple or a tuple is equal to is created by using this type of brackets. And again, what matters inside your terms. So let's try to look at 5 and then minus 10 and then 0. All right, so if you run that and then we check the type of that data type, then it will give us a tuple. All right, so there's an interesting feature on tuples, and that is they are immutable. Immutable simply means that you cannot change or edit this tuple or change anything within this. All right, so let's first try to print out this tuple, print t, and then we'll have it again. All right, now let's try to see if we can have a different tuple t in terms of other data categories. We have 1, 2, 3, and then maybe mixed with a string and 0 point maybe 3. All right, so let's create it that way, and then we can type tuple t, and so that. So again, note that we have included here a different term and a different term. It has, this is a float, this is a string, and these are integers. All right, and both are all swallowed. All right, so in another video we'll try to look at what is immutable and mutable, or you can look at it okay, let's look at it. Mutable or immutable simply means that we can edit or not edit that object. All right, so let's say t, let's grab the second element, t1, we print it out, that will give us 2. All right, let's try to change that element within this tuple, and we can set t of 1. Let's assign it or change it to maybe minus 3. All right, so this will refuse and it will give us an error because we cannot edit anything in this tuple, which is a good feature about tuple, that they cannot be altered. All right, but let's say we wanted to change a list as before, that is under maybe S, capital S, will remove er, which is the second term. So I'll simply go there and say S. I'm looking at the second term, which is in position 1. Remember, Python begins counting from 0, 1, and so on. Let's assign that maybe to 100. All right, so if I run that and then I run S again, it will give me 100 because it has changed this er now to 100. So this is being mutable and this is being immutable. All right, so we can then say that lists are mutable and tuples are immutable. All right, so that is the best definition of mutable and immutable. So let's look at another data type, which is the range. Python has a function which is range, so you can say r equals when we say range from 0, let's say up to 100. What does this mean? It simply means that r now contains numbers from 0 up to 99, that is by the last term minus 1. All right, so if you want to display those numbers, we can simply say print and list them in such a way that so we have r. All right, so we have those numbers out. If you simply call R back, it will simply give you range of those numbers. All right, so but this is the best way you can display all those numbers from that number up to this one -1. All right, so this is also another useful function within Python that can quickly generate those numbers. And if I wanted to maybe to skip at every 2 numbers I skip, then I can simply say R equals range of 0 to 100, then by skipping 2. All right, and then finally if I try to print that out, let's see what it will give us. So it will give us 0, 2, 4, 6 and so on. So this is how you can play with numbers, generate with numbers of a given order and so on. So let's try to look at another given data type. Remember we have looked at the numerical category, which includes integer, float, complex numbers, and then now we are looking at the sequential data type, which includes lists. We have seen what a list is, we have seen what a tuple is, and we have seen what a range is. Alright, so let's jump to another important data type, which is strings. Alright, so let's see what a string is. If I make this my heading, let's look at what a string is. To create a string, or to create this kind of data type, you only need to put whatever you want in quotation marks. Alright, so let's say string equals, so I need to have these quotations. Here we go. So whatever we have here is now a certain data of type string. Alright, so if I run that, then I have my data again stored in the same way, read from this way, because it is under quotation, so it is data. Alright, and then it is assigned to a pointer or an identifier, which is string within the memory. So if I try to call back string, then this will give me here we go as our data produced. So again, in the same way, I can try to look at each of the elements we have here by doing the same thing. Let's say string, the element in position 2, 0, 1 to the third element. Alright, so that means if you look at that, you are looking at here 0, E, 1, and then R, which is in the third number, which is the 0, 1, 2. Alright, so this is R. Alright, so this is how we can handle strings, and most of the operations that apply on the other given data types also do apply on this type of data. Alright, so let's look at another kind of data type, which is the dictionary. Alright, dictionary, so as a data type. So how do we create a dictionary? Basically, to create a dictionary, we need to understand basically 2 things: what is a key and what is a value, because that is its inclusions. So let's try to say dict equals, we create a dictionary using these 2 type of brackets, and then we will have, for example, a name, alright, of someone, trying to get the information of someone, name, which is, let's say, Albert. But because this is a word, right, this is supposed to be in quotes, and that will be of a string type, data type. And then you have comma, and then finally we can record, let's say, age, and that age, let's say that is 40. Right, and so this gives us what we call a dictionary. So if we check just the type of that data, dict, this is going to tell us that is a dictionary. All right, well, I forgot to check out above here what data type it was. How to can check that? You can just type for the string, it was string, and then that could give us str, which is the string. Alright, so this is how we can create a simple dictionary. We need to have our key and then our value. Alright, so these 2 go hand in hand. So if I want, for example, to access the age, then I can simply say dict, and then we are interested in the age, and then that will tell us that it's 40. All right. So that's basically how we can access, and then again dict of the name or any other information, and that will print the name, which is Albert. So basically this is a dictionary. And let's go to another type of data type, which is the Boolean. Basically Boolean as a data type basically looks at two things, that is the false, whether something is wrong, and true, with the capital, the beginning letters to be uppercase. All right. So let's try to see what this means. Let's say we assign x now, because we know what a variable is. Let's have a variable x being equal to 2. It is assigned to 2. So that means and then finally we say, all right, x is equivalent to 3. Definitely what we know is that in our memory, x is assigned to 2. So when we say x is equivalent to 3, this is like saying 2 is equivalent to 3, which we know that it's wrong. It's not true. It is false. When you run that, definitely it will tell us this is false statement, because 2 is not equal to 3. All right. The same thing applies to if we say y equals 2. All right. And then we are assigning another value in another memory, y equals 2, and then we have x is equivalent to y, and I run that. That will give us true. Why? Because x is assigned to 2 and y is assigned to 2, so 2 is equal to 2 is equivalent to 2, and that is true. All right. So this is the Boolean data type that we can deal with in details later, and so that's it. So another common as well is the set, which falls under the dictionary, which is under mapping data type. So the set. So let's see how that can be. And in this way we can say, let's say equals a set, and then we have our list inside of some data that includes repeating terms 4, and then 6, and not well organized, and maybe 3. All right. So we can see that in this list 2 is repeating twice, 3 is repeating twice, and there's some order here that's not let's actually keep this one 7 and keep this one 5. All right. And so there's some non-uniformity right here. So let's run this, and then if we call back s, so let's see what happens. What happens is that s gives us 1 2 3 4 5 7. What does this mean? It means that a set does not have to include repetitions. All right. So for example, 2 and 2 was repeating, it's removed. 3 and 3 was repeating, is removed, so we have only one term. And then finally we have also here 4 7 5. All right. And then it is finally arranged to 4 5 7. So these are some of the characteristics of the sets we can learn immediately from here, before even we proceed further into the intersection, union, and so on. So right now, according to our set objective, we have looked at what is a variable, we have looked at the most common data types, and then we need now to jump to the basic operators and the inputs. All right. So what are the basic common operators? So we are looking at basic operators and inputs. All right. So let's look at what is this. What are the most common basic operators? When we talk about operators, we need to see how we can manipulate all these data types. All right. So under operators, we refer to the operations under say addition, which is represented by plus, and then we'll look at multiplication, which is given by star, and then we'll look at division, which is given by this slash, and then we have power, which is given by these two functions, either by calling power or by using a double star. And then also we have addition, multiplication, division, then we have subtraction, all right, which is given by a minus, and then we have the remainder functions, or which is the modulo, all right, given by percentage, and then we have the floor also and other terms. All right, so let's try to first of all look at these very basic ones, and then we'll proceed and as we build on this. So let's begin with the basics by setting x equals 3, y equals 5. All right, so that means in the same way Python is storing 3 and assigning its identifier as x, and then likewise here. So by testing addition, if we say z equals x plus y, and then we call back z, so this will give us 3 plus 5, which is y. All right, so I'm going to keep using the same variable z since it can be changed. All right, by using subtraction, this will be y minus x. All right, and then we call z, this is equal to, and if we call z, that will give us 5 minus 3, which is a 2. So let's get to the multiplication. If we have x multiplied by y, that definitely will give us 15. Z called z, and that's 15. So basically we have seen what addition, multiplication, subtraction, and now we can look at the power. All right, so z, let's set z being equal to 5 power 3, that is y, to the power of x. All right, that is 5 power 3, that is 125, and if I call back z, that will give me 125. So you can either approach it this way by using double star the power, or by simply saying let's say r equals using the function power, the number you want to raise, which is y, and then the corresponding power, the one raised up, which is the x. All right, so if I come down here, r gives me 125. So you can either do it with this power function or just with a double star. I tend to find double star much easier as compared to this one. All right, so let's look at now finally the modulo and see what it means and how we can use it. Let's say d or m is y percentage or modulo of x, and we need to know what is m. So what does this mean? This means that we are trying to find the remainder when y, which is a 5, is divided by x, which is a 3. All right, so m should be the remainder when we have that operation, and if I do that, it gives us a 2, because 5 divided by 3 definitely goes there once, and then the remainder is 2. All right, so that is basically the remainder function, and it is very helpful when you're trying to look at numbers, looking for even and odd numbers. Let's try to demonstrate this with a certain small function here. Let's say I create a list which is equal to list of all numbers from from 1 to 100. all right, so this is a list, and I'm making a use of the range function. And then finally, when we generate L, I can say that I can use a for loop, which we'll look at in much details later. For I where is any number in L is the list which we have already generated. For I in L, let's put a condition. If that number I is divisible by 2 and we have a remainder as 0, alright, so what happens? We will say print the number is even, and then we can print out that number I. Alright, else else it will imply that that number is odd, so we can just print out the same number which is odd. So I'm using the same statement, I'm just changing this number here. Alright, so let's try to run this and see what happens. So it's giving us 1 is odd, 2 is even, and so on and so on. Alright, so let's try to change this same program in such a way that it would add numbers in their given lists. Let's say we'll create a list here. Let's say E being equal to an empty list of even numbers. So we need to make our program more readable by commenting on it. This is even list, even empty list. Alright, and then we have O here being equal to odd empty list. Alright, so what does this mean? It simply means that we have now created empty list and we want to throw things here, numbers here, even numbers here, and odd numbers here. So the way to do that is that I'm going to use another function we'll learn more about later, which is called append. So I'll get this list and append all the numbers within that manually. So that means E dot append I. If at all a number is divisible, that number is going to be thrown in the even, and then I'll keep this out, and then else we can now move to the else part. If it's odd, else it's O, the odd dot append I. Alright, so now what we're going to do is now to print out this out, everything out. Print we can print out E. Alright, and I need that on a new line, so on a new line, and then I print out O as well, which is the set of odd numbers. So if I run that, I'll have 2 running up to 98, and then I have the odd parts running up to 99. I can put in more in a more descriptive way. I can put some descriptions here and can say that the even list equals, then I can put that on a new line by using this command, and then right here on a new line, again on a new line, I can put the list of odd equals, then on a new line, then n. Alright, so if I do that, you can see the different changes. Alright, so let's look at some of the more calculations that you can apply using these basic operators in Python. Alright, so let's assume we need to calculate a certain expression given by maybe d equals square root, alright, of maybe what is inside x squared plus y squared. Alright, let me use that for the moment, and that's what we need to calculate, assuming x is given and y is given to you. Alright, so let's try to do that and you see using the two options. So we will say d equals square root as a power means a half, so I can use the first option which is the double star. So I'll have that. Let's first define x. X is 2 and then y is 4. Alright, so d becomes brackets, you have x double star which is squared, then plus y power 2, alright, and then everything is raised to power 0.5. So if I print that, end it with a d, if I print that, it will give us d equals 4.4 and so on. You can see the simplicity of this function, right? But let's say we wanted to use the other option of POW power, then it means that we need to, because it has a square root which is a power, so we need to begin by defining defining our power, which is power, and then remember the expression here has to end with the power, which is the 0.5. all right, but what we have here inside is the x squared plus y squared. So I can open up new brackets, right, and then inside we have again power of x, and then the power is 2, all right, and then plus power of y, the power is 2, all right. So this is the sum we have here, and then finally the power is that. So when I run that, I have my d equals 4. That in the same way, but see how this one is a little bit harder to configure than this one. So in my opinion, I tend to go in for the double star as the power. So basically that is how you can manipulate expressions using the multiplication, divide, subtraction, the remainder, and so on.